Welcome to the final chapter in the Exploration course, Routing Protocols and Concepts. You've come a long way since the first chapter on routing and packet forwarding, and you should be at ease with the concepts covered and skilled in the lab activities when you're done with this class. Ospf is a link state routing protocol that was developed as a replacement for the distance vector routing protocol, RIP. Ospf is a classless routing protocol that uses the concept of areas for scalability. Cisco's iOS uses bandwidth as the cost metric. The major advantages over RIP include fast convergence and its ability to scale to much larger networks. Because RIP uses only hop count as its metric, it may create paths that are not optimal, whereas Ospf will choose the fastest route to a destination even if it must traverse more hops. Convergence is faster with Ospf because, unlike RIP, updates are only sent when changes in the network occur. In large networks, convergence could be on the order of minutes with RIP. Recall, RIP routers go through a period of hold down and what is sometimes called garbage collection before they slowly time out information that has not been received recently. This is inappropriate in large environments and could cause routing inconsistencies. The use of Ospf ensures better use of bandwidth, and Ospf allows for better load balancing. This slide shows an Ospf packet. This packet contains most of the elements you will study in this chapter. You will learn the various packet types used by Ospf, how routers get a router ID, how to establish an area for your Ospf network. And like RIP v2 and EIGRP, you will note that the network mask information is exchanged. As you configure Ospf, you will learn what the hello interval is and how to adjust it. You will see how each router gets its priority, and you will learn how to change that priority depending on network needs. Information about which router is in an area and which is a designated router and which is the backup designated router is included in the packet, as is a list of the router IDs of neighboring routers. And if at this point you are suspecting this is a dense chapter, you are correct. Make sure you plan enough time to absorb the information and practice the labs and activities. Each Ospf router maintains a link state database containing the link state advertisements, or LSAs, received from all other routers. Once a router has received all the LSAs and built its own locally significant link state database, Ospf uses Dijkstra's shortest path first, or SPF, algorithm to create an SPF tree. The SPF tree is then used to populate the IP routing table with the best paths to each network. I hope this brief overview of Ospf will give you a good starting place for the chapter. Ospf has many properties and configurable parameters that you will study and practice. Congratulations on your progress, and good luck as you end the course.